Today we'll make our first tree in Unreal Engine, and hopefully it's the last stylized tree tutorial you'll ever need. After years of studying professional game art and creating 3D art from scratch for game studios all around the world, I've turned my stylized tree workflow into a brand new Blender add-on that helps you make amazing trees in just a few minutes with no previous experience. But understanding how to use this tool for game engines is a little bit of a different story, so today we're going to dive in and become tree masters. I'm Shane Ghidorah, and I want to make 3D art easier to learn for everyone so people of all skill levels can come together and create amazing things. TREEBOX for Blender is my brand new add-on that lets me generate stylized trees in minutes and does most of the heavy lifting for me. So we'll dive in and learn how to use TREEBOX, how to create trees, and how to export them into Unreal. And we'll build our first tree shaders for game engines and pull off a couple lighting tricks to make them as painterly as possible. By the end of this video, you'll never have to waste a day duplicating cylinders again, and you can use the tree shaders you make to create an infinite amount of trees. You can get TREEBOX right now below the subscribe button and get 25% off all my products when you join my Discord channel where we make game art together and get actual career advice. Okay, let me wrap it up and we'll make a tree together. If you have Blender open, just go ahead and delete everything and we'll open up the preferences. If you have TREEBOX, awesome, but if not, it's now out on my Gumroad, and in this tutorial, I'll be showing off one or two of the pro features as well. Now, the actual add-on is in the unzip me folder, so once I extract it, I'm going to go ahead and install from the disk and then find the zip folder. There it is. I'll just click install from disk. We need to tell TREEBOX where our asset library path is. We can do it through the preferences or through the add-on itself, which is now in the end panel. I'll go ahead and assign the asset library, which is also in the unzip me folder. There's the library, and I'll click accept. Now, creating a tree is as easy as clicking create tree. The default preset doesn't look that bad, but we have a whole host of options in the modifier stack. I'll dive right in and go ahead and draw my trunk by clicking draw trunk, and in edit mode, I can use the draw tool to the left to actually just draw whatever I want. So I'll delete these vertices and then I'll start from the bottom and drag upwards. Move the topmost vertices so that the trunk knows where to go. Now, I'd like to point out the distortion scale, which is the strength, and the noise scale, which is the size. Playing with these two parameters can really mess up your tree in fun and interesting ways. If we go into the wireframe preview, we'll see that the topology is actually quite considerate of game engines, but you're not stuck to this resolution, so you can change the cylinder size and the curve resolution for the trunk and all of the branches. In the next section, called the primary branch, I'm just playing with the parameters that catch my eye first, like the bend and the length. Below each branch section, there's actually a transform section where we can change the rotation and how the scaling operates on this tree. So dialing in the parameters between the transform and the main section allows me to have a lot of fun with different parameters like the radius, thickness, and flare. I would actually recommend going back to the trunk section so you can find that perfect balance between the primary branches and the trunk. If you want to get extra crazy with the distortion, I recommend hopping into the wireframe preview so that way you can really see how the topology, the thickness, and the distortion are all interacting with each other. If we want to start changing up the silhouette of this tree, we have a count parameter and a seed parameter in each of the branch sections. That way we could really change things up without too much effort. And once I'm happy with how the actual branches look, I'll start playing with the start and end range of each branch section. This gives me a lot of flexibility with the shape, and it can entirely change the look or species of your tree. Once you're happy with your branches, we can finally learn how to make leaves for this guy with the canopy system. I'm going to create a canopy. These procedural canopies have allowed me to create an infinite amount of fluffy trees. This process is pretty forgiving, and what you see is what you get. We're looking to edit the card size, the canopy size, the rotation, and some of the density. If we go to the material preview, we'll see that TREEBOX comes with a collection of pre-built materials in Blender so that we have an easier time with look development. TREEBOX Pro comes with more so that you can have an easier time changing up the season. I'm dialing in the settings until I accomplish what I think is both an optimized and a fluffy bush that I can spam all over my tree. For optimization purposes, I've also included a leaf card mode where you can change it from single to double to triple depending on how crazy you want to get with the fluffiness of your tree. If you're doing a Blender only render, I've also included a billboard mode where all you gotta do is spawn a camera, assign that camera to the canopy generator, and the leaves should follow that camera no matter what angle you're looking at. If you want to make something a little bit more complex, we have the model canopy mode where it's smoothing out any custom topology we want to give it in edit mode. Once you're finished with your bush, it's time to head back into the tree generator, and the last two sections are dedicated to spawning these leaves. I'll switch to leaves active mode, and we need to give our canopy a unique collection, just in case we wanted to have multiple objects in one spawning system. With the M key, I'll move my canopy into that canopy collection, and I'll just place that new collection into the tree generator. It'll grant your wish and give you a tree. All of TREEBOX's systems are working together to smooth out these canopies for a really stylized look. This is still a fully procedural system, so I'm still optimizing the canopy and changing the count and seed of this leaf scattering. Just like the branches, the leaves have a transform section as well, so I'm just changing up the start and end range to dial in my look. I think it came out quite wonderful, and it really didn't take us that long. In fact, we still have time to make one more tree that shows off TREEBOX's volume scatter mode, so I'm going to duplicate these two systems and drag them over. I don't want to deal with the previous canopy, so I'm putting our new canopy in a new collection. These could share the same collection, but I really want to show off the volume scatter mode. Volume scatter in the canopy generator will turn it into a small object, and in the tree generator, before I turn on volume scatter, I'm just going to double check the volume preview to check that every little sphere that's going to spawn our canopies are the right size. If it looks okay, head back into the tree generator, and let's go ahead and switch the collection to the new canopy. Now we can switch it to volume scatter, and we'll see that those little objects are now spawning all over those radius spheres that were then volumized into one single mesh. You can go back into the canopy generator to then start dialing in the density compared to how the tree generator is spawning them, and playing back and forth between those two systems is how you create the most unique tree. Optimizing your tree within this workflow is all about finding that balance between the density and the leaf card size, and then throw a last Hail Mary at the seed to find the shape you like the most. So even though they're the same branches, they're using a totally different scatter system. Now, instead of doing an extra hour of prep work, we're going to do something crazy and click Tree to Mesh. This just did a lot. If you want to learn more about it, feel free to check out my previous TREEBOX video, but I'm just going to click Tree to Mesh and it's ready for Unreal Engine. For those of you with TREEBOX Pro, we're also going to add a little pine tree generator. The parameters for this tree generator are definitely a bit more simpler than the original tree generator, but we still have fun options like drawing the trunk, changing the size of the leaves, and I'll be adding support for custom cards in a future update. Click the bonus to mesh button at the bottom of the add-on for either the pine or ivy. With 3 finished trees, all I need to do is bring them back to the center with Ctrl G and apply the transforms. Now, I'll just export the FBX and apply a couple settings like selected objects, mesh, and for the geometry smoothing, I'll select face. For the bark material, I'll be using the Arid Bark Pack from Mattbox, but that's also included in TREEBOX Pro. Like all internet downloads, I'll make sure to extract the file so I can have it ready to import into Unreal Engine. And TREEBOX comes with the textures originally used in the add-on, so we can extract those too and use the leaf textures in Unreal as well. All you need is a black and white image of a leaf texture of your choice. If you want to learn how to draw them yourself, or you want to create this entire environment with me, feel free to check out the course I did with Fast Track. Now it's time to open up Unreal Engine. I'll open up my demo map, which is simply just the grass tutorial I did with Fast Track tutorials as one of my first ever YouTube videos. You can check that out on their channel as well. I'll make a new folder to place our assets, and the first thing I'll hunt down is that Arid Bark Pack. There's 4 materials. I'll open up one of them and get the textures folder. I want to import the base color, normal map, and ORM map, which I'll explain in a little bit. And in case you didn't have time to draw your own leaf textures, we're just going to import the TREEBOX original leaf textures into Unreal as well. You can pretty much import any of these assets. So now we're going to drag in our tree FBX, and there's a lot we got to uncheck. By default, it's going to override our normals and tangents, and we want to turn those off. We also want to make sure combined static meshes is checked off so our trees don't get combined into one. Now in static meshes, check build and uncheck build nanite. Now let's turn off import features like skeletal meshes, morph targets, animations, materials, and textures. If TREEBOX did its job correctly, then we now have a procedural system of trees that were then turned into static mesh trees for game engines. After double checking and making sure our trees are error-free, we're now going to create our first material. For the bark, we'll call it M_trunk. Let's open up our master material, and then I'll make a little space so I can see all of my windows. Let me use the content browser to drag in my textures. We only have to make these materials once and never again. I'll make some room for my color and I want to multiply it by a vector 3 by holding 3. I'll convert it to a parameter by right clicking and then I'll call it tint. We don't want to multiply it by black, which is 0, so I'll switch it to white. Now I'll add a lerp node that lets me blend between two different colors. I'll add a new color and I'll call it top color. I'll change it to a mossy green because I want moss to come from the top of this object. But how are we going to do that? Well, once we plug that into the B channel, let's get a new node called World Aligned Blend. This node generates a position-based gradient that also blends with the normals. I'll right click and promote blend sharpness and blend bias to parameters, set sharpness to 2, and I'll get rid of those little S marks. When I plug it into the alpha, we'll notice the position works, but we still have to get our normal map working. So I'll go down to my normal and add a flatten normal node. I'll hold S to add a scalar parameter, call it flatness, and I'll just input that into the normal. Now we can look at our ORM map, which is the occlusion roughness metallic map. By looking at the pack texture, we'll see that red is occlusion, green is roughness, and B is metal. Bark doesn't usually have any metal, so it's not in this texture. So we can start plugging them into the appropriate slots. I want a multiply node for the roughness, like I said, S for scalar parameter and call it roughness, that way we can control the strength. I'll leave it at 1, and we can plug in our metal. Now we can see that the world aligned blend node is successfully blending with the normals of our material. All we need now is a 3-node setup of the texture coordinate node, and a multiply node, and a scalar called tiling, and that way we're able to control the tiling of the material. I'll go ahead and set it to 1, and we'll plug this into the UV slot of each texture. To edit the textures in our instance, we'll promote them to parameters and give them names like base color, normal, and ORM. So believe it or not, this is our finished trunk material. We can go back to the master material that we've created, right click it to create a material instance, and I'll call it MI material instance, trunk. Opening up this material instance will show us that the parameters we've made are now ready for real-time changes. For this material, we have the option to change the blend amount, the moss color, the tint, and the tiling. I'll use the highlight tool in the mesh window to find the material instance, and then I'll place it in there, give it a quick look, and if it's looking good, I'll place it on the rest of my trees. With our bark shader finally completed, it is time to move on to level 2 with the foliage shader. This one is a little more difficult, so take a break if you need, but then let's call it M_foliage and hop in. Now, this isn't a default material, so let's go ahead and change just a few settings. I'm going to change the blend mode to masked, and I'll change the shading model to 2-sided foliage. If you're feeling fearful, check 2-sided right below it too. So we'll hold 3 to add a vector 3, and then I'll promote it to a parameter and call it the top color. We're going to blend this with a gradient, so I'll make this the lighter color, and then we'll duplicate this and call it the bottom color. Foliage in Unreal tends to get pretty bright, so I'm making these colors fairly dark. To generate our gradient, we'll get a new node called the bounding based 0 to 1 UVW, and if we add an add node, it'll let us move the gradient around. Let's add a scalar called gradient offset and plug the result into a cheap contrast node, which lets us control the sharpness. We'll get a scalar and call it gradient contrast, plug it in, and now let's invert this with the 1- node. And just so that we don't break anything, let's get a new node called saturate. That is the gradient we need. Now, you might notice that the output is very, very bright, and we'll fix that in a little bit. For now, let's look at the specular and roughness, and I'm going to add 2 scalar parameters. For specular, I'll set it to 0, and roughness, I'll set to 1. That means no reflections at all for these stylized trees. Before it gets messy, I'll start commenting this out so we can make some room for the next section. Let's create the opacity by adding a new texture sample by holding down T and converting it to a parameter, and we'll call it opacity. In the texture section, we can look up our leaves and pick the one we want. For now, this is going to be super simple and we'll leave it in the opacity mask. I want both sides of the foliage normals to be flat, so I'm going to add a vector 3 parameter and boost the B channel all the way to 1. We'll get a multiply node and plug that result into the B channel, and for the A channel, we'll get a new node called the 2-sided sign. That way, this flat normal applies to both sides of the foliage, and we just plug this into the normal. Now, in order to fix our super bright foliage, we're going to go ahead and add our subsurface color. I'm looking for a brighter tone than our original base color. I want to be able to blend this with a lack of subsurface, so by holding 1 and adding a constant, and then using a lerp to blend between the two, we can get the subsurface stronger on the edges with the Fresnel node. I'll just promote the exponent parameter to a scalar parameter and call it our subsurface radius. All we need to do is multiply this value and create a scalar called subsurface strength so that we can control the strength and then clamp it in the 0 to 1 range with our saturate node. Let's plug this result into the subsurface color. The Fresnel node is allowing our subsurface color to be stronger based on the camera angle. Wind for our foliage is easy. All you have to do is add the simple grass wind node and then promote the first 3 slots to parameters. I'm going to get rid of the S marks in the parameter names and then set each value to 1. Now the complicated part is the additional WPO. We're going to develop a special billboard shader function that'll project our leaves towards the camera. Just follow along with me at this part. Let's add a texture coordinate node and we'll plug this into a 1- to invert it. We'll plug this into the A slot of a multiply, and for the B slot, let's add a constant at the value of 2. We'll plug this into a subtract node and we'll have to hold 2 to create a new vector 2 with the x at -1 and the y at 1. Now for this math to work, we have to add a new vector with the append vector node. We just need to add a constant at 0 and plug it into the B channel. Now we need to add a new node called the transform node. We need to change the source to camera space and then the destination to local space. Now from the transform vector, we need to normalize them, so we'll use the normalize node, and then we'll multiply them and simply add a constant at 1. So right now, we've effectively transformed these vectors, and now we're going to take another transform node and simply take the source and change it back into local space. We'll keep world space the exact same. Now, let's add an add node and plug the transform vector into B, and with a new node called the vertex normal world space, we're going to add a scalar called billboard inflate and multiply them together. I'm holding M to add one more multiply node and S to add one more scalar called billboard scale. This complex math function is now complete. We can call it the special billboard algorithm and just plug it into the additional WPO, and then plug that final result into the world position offset input. Now, one more thing I'd like to add is the ability to add a custom color texture. So by holding T and converting it to a parameter, I'm going to call this one base color and add our pine leaf texture. I want to overlay our original color work that we did on top of our pine leaf. So I'm going to use a multiply node and plug the pine leaf into A, our original work into B. I'm going to use a lerp node to blend between the original texture and our multiply and make a new scalar called tint strength. Now, to switch between these two different modes, we'll add a new node called the static switch parameter. I'll name it something like use color texture. We'll plug our colors into the false channel and our new blend into the true channel. So if it's true, it'll use the color texture. Now, besides the shader function that I'll show you towards the end, this is our completed foliage shader. So now we can create material instances based off that master material we've completed. I want 2 for both of our tree types. We can go ahead and hop into the settings and see if the use color texture works correctly for the pine leaf, and it does. With our materials finally completed, I'll use the content browser to assign these materials to our static meshes. I want to show you how to prepare these trees for a non-ray trace scene at the end, but for now, our trees are ready to populate with ray tracing and lumen. So let's place them in our scene and see how they look. If your trees have this weird shaky effect in the shadows, select all of them and go ahead and click Evaluate World Position Offset in Ray Tracing in the Details panel. I'm going to increase the tint strength and the top color brightness on this pine tree to better match the shading of our current trees. I'm perfectly happy with how the shadows and the subsurface came out. Even a default lighting setup in Unreal Engine interacts with these trees really nicely, but we'll notice these really sharp planes and shadows, which are obstructing the soft nature of the stylized look we're going for. So we'll create a non-ray traced material function that'll hide those planes depending on the camera angle. I call it the crossfade function. At the end of your opacity map, let's add a new static switch parameter and call it use crossfade ? We'll put our original work into the false slot, and for the true slot, we'll do a little bit of math. Let's plug our work into the B channel, saturate it to clamp it, and plug it into true, and double check it's connected. Now we'll use a new node called the world position node, which generates gradients on all axes, and we need some new nodes called DDY and DDX to plug that into. These are then plugged into a new node called the cross product. Now let's normalize these vectors with the normalize node. Now I want to plug the normalize node into the B channel of a dot product node. And for the A channel, I want to plug in a new node called the camera vector world space. We'll just plug it directly into A, and the absolute value node, or ABS, will let it always be positive. This can go into the final result of the multiply, and the function is ready to go. But it only works with ray tracing turned off, so turn off ray tracing on both the sun and the skylight. All we need to do now is open up our material instance for the tree leaf, and let's go check out the use crossfade static switch. Now those harsh perpendicular planes are being hidden and the shadows become extremely lush. After all that math, we're finally free to be able to place our trees as we please and build our forest. What really excites me during this process is knowing that after doing all of that shader work, we have a beautiful collection of materials that we can reuse and remix over and over for any of our TREEBOX trees, or even trees or foliage you create without TREEBOX. And creating complex forests can actually become fun. If you remember our billboard function, I like to use it as the final touch to increase the fluffiness of my stylized forest. If you're happy with your scene, you should let me know what you want to see next in the comments. Thank you so much for watching. I hope these tools and videos can help you actually get the job done and make your entry into the indie game art world a little bit easier. If you want to see how to create this exact type of tree but without TREEBOX, you should check out Victoria's channel, who basically paved the way for this research. I'll make sure to link her channel down below too. And thank you to the 1,000 artists that are using TREEBOX today, and thank you to both Superhive and Fast Track Tutorials for helping me get the word out. If you think this video could help out other 3D artists, then make sure to share the video. Because of you, I have some amazing new game art tools, tutorials, and videos coming out soon that you are not going to believe, so you gotta make sure to subscribe. Okay, so enjoy your trees, and I'll see you guys next time.